So we're delighted to have a fantastic panel here to talk about artificial intelligence. And actually, I think I need a bit of artificial intelligence myself to put myself on a panel here with such a distinguished group. We have Werner at the end here, who is the CTO of Amazon. They have some very interesting implementations of machine learning throughout their entire company and offering, and we'll be talking about that. With Ben and George here, we have the two founders of a couple of very interesting companies that are using artificial intelligence to create a lot of benefits for consumers and for businesses. George is the founder of Rocket Fuel, went public last year. Ben is on the founding team and CTO of SwiftKey. And we have Manoj, who is at IBM responsible for Watson, which is obviously an iconic implementation of artificial intelligence, and we'll be talking a little bit about that. So let's get started focusing on some definitions. What do we mean by artificial intelligence? It's quite a slippery concept. Starting with George and with Ben, you guys did a long sort of academic study and research earlier in your career into the field of artificial intelligence. Can you tell us a little bit about the field, where it came from, the research over the last decades and academic frontiers, maybe starting with you, George?
Sure. I mean, personally, I got really excited about AI in the 70s, watching Star Trek and the ship's computer. Tried to build it myself with my Radio Shack 150-in-1 electronics kit, but then realized with about 10 resistors, 5 capacitors, and 1 AND and 1 OR gate, you're not getting there. So I had to go to Stanford to learn more about it. And it was a cool time in the late 80s and early 90s. John McCarthy was still there. My advisor was Nils Nilsson, who really developed some fundamental algorithms. And it was actually at a time, though, when I think AI was just beginning to kind of get disappointed with itself as a field and kind of lose imagination, right? For a while, they really thought by the 70s or something we'd have robots walking around and sort of being our virtual or real servants. And I think it was just beginning to realize that it aimed so high. All of a sudden, people stopped believing sort of in strong AI that you would ever be able to replace human functionality. And so the field kind of fragmented into machine learning and natural language and a bunch of other pieces. And I found machine learning most exciting just because it was an area where you could achieve sort of superhuman effectiveness, by analyzing data to make decisions versus, human-style models. And so that's what I've been doing since, really, mostly in the marketing field.
Ben, your research focus was on natural language processing, but also with a machine learning element to it as well.
Yeah. I think it's a field that really captures people's imagination. And if you look back to how computer scientists try and define AI, they often look at whether a problem is compressible. So the question is it possible to write down a set of rules that can solve a particular problem to a reasonable degree of success? And if that's not the case, then it tends to get sort of lumped as an AI problem. And to solve AI problems traditionally, you essentially have to search through possible solutions to come up with a good one. As George mentioned, I think the AI has become a very large umbrella that covers a lot of different areas.
It's really a family of technologies as opposed to a specific technology.
Yeah. And how you define intelligence, obviously, it's something that everybody has an instinctive feel for, but that can be quite unhelpful, I think. So the way I like to think about the field of AI is it's around dealing with problems where uncertainty is a core element of it.
Right.
And that kind of harks back a little bit to the roots, but all of the different ways of addressing it, I think fundamentally are to deal with the fact that the world is an uncertain place, and we have to find a way to deal with that.
Right. And what's special about what computers can do now that they couldn't do before to address that?
So what's interesting, of course, is that computers themselves haven't really changed at all. The architecture, the hardware architecture of computers is pretty much the same as it was when von Neumann sort of described it, way back in the day. But what has changed is that the models that sit on top of that within the software layer to represent and solve problems. And that really has changed.
In what kind of ways? Elaborate a bit on that.
So I think we briefly mentioned machine learning. And machine learning to me, is a fascinating paradigm because it allows you to solve a class of problems that were insoluble before. And essentially, again, looking at this question of how you represent problems, and if you can't, for human language, for instance, you simply can't write down enough rules to cover all of the edge cases. So what machine learning does is within the software layer, it creates a framework whereby a machine can look at past data in order to make future predictions.
Right.
And then this whole class of problems becomes solvable in a way that simply wasn't the case before.
Effectively, the computer becomes self-directing without requiring human intervention.
Yeah. The programmer, rather than writing the rules for what the system does, writes the framework within which the system then learns to solve a problem.
So Manoj, bringing you in here, I mean, IBM Watson is really an iconic implementation of AI. We think of chess and Jeopardy. Give us a little bit of the history, how IBM got involved in this in the first place, working on these kinds of problems.
Sure. So Watson, and from the get-go, I look at it more as augmented intelligence rather than artificial intelligence. And I'll talk about that a little bit more later. It's about extending the human capabilities. It's about man and machine, not man versus machine. With a brief history of Watson, I mean, every 10 years or so, IBM Research takes on what we call as a grand challenge. We spend $6 billion a year. It's the largest math department in the world. And last time that we had taken that on
So it was literally a science project.
It was actually starts as a science project to show what it is that computing can do.
Right.
And in the 80s, we did the Deep Blue, the grand challenge, where we took on chess as a computational challenge and beat Garry Kasparov. And that gave us a whole new range of technologies, the IBM mainframe, the power systems.
But Kasparov was a little sore about that.
But if you have followed what's happened after that, the entire game of chess has changed, where it is not about man versus machine, it's about man and machine working together to take the game to a whole different level. I believe that's the same thing that's going to happen with Watson and technologies like that. So coming to Watson, in the late 90s, we started looking at this whole area of processing natural language. So in 2006, IBM Research created a project to go take on Jeopardy, which is a US quiz game, to show that computers can understand and interpret natural language at a rate that is faster than the human brain. And in 2011, on Valentine's Day, we successfully competed and demonstrated, and then I got the privilege to be asked to what I talk about as converting smarter to richer, to commercialize the technology, and that's what we've been doing.
Right. Werner, just to bring you in the discussion here. So, from a consumer standpoint, I think many people's first interaction with machine learning is through the Amazon recommendation engine. That's been around for a decade or more now, and one of the key drivers of the growth and success of Amazon. So that was the first, I would say, at-scale implementation of machine learning for consumers. Amazon, however, has rolled this out throughout the entire business now, through the front end to the back end in AWS. Can you talk a little bit about the scope of machine learning and artificial intelligence within Amazon now?
Yeah, so that's not, the artificial intelligence piece of it sounds really more like sort of science fiction side, but machine learning is actually not as esoteric as that it looks like. Basically, what you try to do is you try to have information from the past to make predictions about the future. And actually, it's pervasive throughout an organization like Amazon. It's not only that the customers interact with it, for example, through recommendations, but also, for example, through predictive search, which is a similar kind of application. But within, let's say, the core of the business, there isn't probably an area that is not touched by machine learning. Basically, what you try to do, you use data to make really good decisions about the future. So take retail itself. So the retailer, the guys that need to do the buying, so demand forecasting, vendor lead time, a decision how to set pricing. All of those things are basically machine learning processes. Yeah, and
why not have a bunch of smart people working on those kinds of problems? I mean, do you do it because you can, or do you do it because it's better?
For example, take recommendations. Recommendations is something that you want to do in real time, within tens of milliseconds, to make a decision for a customer based on location, based on geography, based on representation. So there's many different factors that go into sort of making a prediction for the customer.
So it's beyond the capability, really, of humans, the scale of the decision, the data that's being processed there.
Absolutely, but also accuracy. I've seen, I remember the time when we used to have just a few guys who would make decisions about sending marketing emails to our customers, and they were doing really well. Until a moment, because they had good intuition. And so, but at one moment, the intuition tapers off. There's no longer an effect that the collecting data at scale would give you a much more finer-grained recommendation, for example. And so, really doing this by automated algorithms, you're able to continue to actually do this. A great example, actually, outside of Amazon is something that GE did a project together with Mount Sinai Hospital where they instrumented every patient and every object that actually moved throughout the hospital. Normally there was 2 guys that would be sitting at the intake desk that would decide where a patient, in which room they were going to be placed. And they did this with great intuition throughout the years. But it turned out by just collecting data about how patients move through the hospital from one, let's say, diagnostic room to the other room, they're able to actually optimize that much further than just what these 2 guys were able to do. I think they saved Mount Sinai Hospital something like $20 million, no, $200 million, while being able to manage 10,000 more patients a year.
So let's pick up on that theme. So I think around optimization, a lot of the best ways of doing things are actually counterintuitive. So George, talk a little bit about some of the findings that you have when you point your algorithm at advertising decisions on behalf of your clients and things that come out of that are counterintuitive.
Sure, I'll mention, right now I'm CEO and a founder at Rocket Fuel. We're about a 600-person company, and our systems evaluate about 40 billion times a day. We sort of get a poke saying, would you like to buy this one ad spot right now, whether it's video or Facebook or display? And our systems, as Werner was talking, just have milliseconds really to decide. And we don't really have humans in the loop trying to say, well, here's how you sell cars online, or here's how you sell shampoo. It's all machine learned, and like you were saying, it's a framework we create. But then it's really just a kind of a predictive model factory that's running and improving the models all the time.
Just to pick up on one thing you said there, so the way in which you're approaching this is that you're replacing humans. You want humans out of the equation in the actual, whereas the way Manoj was talking earlier on about augmentation and not replacement.
Yeah, separate thread. I think our customers would be unhappy to hear that we're plotting their demise. I think particularly in advertising and marketing, you can imagine, there's still a lot that does require intuition and creativity around the art of the persuasion and the message. But I think once you have a set of messages, then it's really 100% science, getting them in front of the right people at the right time. So in terms of kind of unusual findings, just one example was a very strong one, selling luxury cars in the US. We found a strong pattern that Hindustan Times and NewDelhiTV.com were 2 of the best sites that our algorithm loved for serving car ads. And it just turned out it hadn't occurred to us, but there's actually a pretty strong demographic in the US of well-to-do Indian expatriates who've got themselves into excellent careers in the US and are well qualified to be consumers of luxury cars. So there's a lot of things that come out like that the people driving the system would never have told us about, but that we find. Sometimes it's obvious too. Like it turns out, if you want to sell pizza to be delivered, you should target engineers around dinner time, and then again around 11 p.m. But we found a cluster we didn't know about around early morning orders coming from businesses that are sort of ordering for a lunch pickup later. So anyway, you find a lot of stuff that people just didn't expect in the data before.
Ben, talk about how you've implemented AI in the human-computer interface and a little bit of the scale of how you've managed to get this implemented now and the benefits to consumers as a result of that.
Sure. So SwiftKey is a predictive typing technology. And what's really interesting about typing is that about 10 years ago, when touchscreens started to become ubiquitous, the problem of typing fundamentally changed. And to the eyes of the consumer, it didn't necessarily look that different, but to the eyes of somebody trying to solve that problem, it's completely different. So traditionally, typing is a mechanical problem. You press a key, and that needs to be translated via some series of impulses into a character on the screen. As soon as you're dealing with a touch screen rather than a mechanical key, you introduce uncertainty into the process. And this comes back to what I was talking about earlier. So once you have uncertainty, it's now an AI problem. It's a machine learning problem. So in order to solve the problem of typing on touchscreens, what you're actually trying to do is guess what somebody is trying to say based on all the evidence that you have. Not just about how they interact with their phone and how they use language, but like George was saying, learning as much as you can from all of the background data that you gather. So what we did was to take a problem that traditionally had been really very simple and to try and solve it using the techniques of machine learning. So we scraped all the text off the internet to gather a very wide language models about the way people use language. And we build models that track every time someone touches the screen on their phone and build up probability maps of where they're going to tap. And then bringing these pieces of evidence together, we're then able to predict what it is that a person is most likely to say. And essentially what you're doing is modeling behavior. We want to have a process running within the phone that is as good at guessing what you're going to say next as you are at guessing yourself what you're going to say next. And
what are some of the strategies do you deploy to make that more accurate? I think we've all had experiences of where the next word comes up, it's not quite the word that you're looking for there. It goes in anyway, you send the email, and then you've had a bit of a unfortunate outcome there in what you're trying to do.
Yeah.
But clearly this is improving all the time. And what are the strategies do you deploy there?
So this is a great question, and machine learning fundamentally is about being able to come up with metrics that give us a feel for how accurate we are. So for instance, with SwiftKey, we're able to simulate typing using probabilistic models that make mistakes in the same way that humans make mistakes. And then we can tweak the algorithms such that metric starts to improve. So we can look at the number of mistakes that a person makes per every 100 words of text or something. And we can train what the way the algorithms work is that they have a target. So you're training towards optimizing some kind of end goal. But what we can also do is take feedback from the market. So one of the things we could do through the app is to track on aggregate in an anonymous way how accuracy is trending across the world. And again, you can tweak algorithms and provide updates and then see how that's evolving.
Just tying it to what Werner's up to at the moment, the cloud with AWS. How's the cloud an enabler for what you're doing? How is AWS potentially an enabler for what you're doing? And then from your perspective, Werner, what's the opportunity in providing cloud services around this, for your customers?
So I was thanking Werner earlier on because AWS has really revolutionized our business, and we use it across so many areas. I think, again, this is about the evolution of what typing is. It's something totally different now. So when we think about typing, we think about a statistical language profile that represents the way a person expresses themselves. And that needs to be available across all of their devices all the time. It needs to be synchronized between, whether you're typing on a tablet or a smartphone or in your car or, entering text on your fridge, whatever it is. And it's the cloud that enables the building of technologies that synchronize across these multiple devices.
Well, yeah, I think, so not only SwiftKey, we see a lot of new applications arising on our platform purely because now there's sort of unlimited computational power sitting behind a very simple interface. And whether that is a connection between simple sensors. Take, for example, the guys from Dropcam. They have this little funky, camera, internet connected, upload video into the cloud, and then do analysis on the data stream, doing sort of predictive analysis on the data stream to see what is happening there. So basically, you can point the camera at your door and you can ask for getting alerts when someone comes in the door. Well, you have to be able to recognize that there is someone coming in the door, not the dog or anything like that. And so there's a lot of things happening where, you know, very simple devices, very simple, what for the consumer looks like a very simple interface, very simple device, which is actually powered by enormous computational engines at the back end. And it becomes even much more interesting, especially with applications like SwiftKey, where this needs to happen in real time.
Right.
And in real time in such a manner that the consumer doesn't realize that there is actually massive computational trees at the other side working for you.
I mean, you're obviously providing, you know, gigantic processing capability, storage, instantly available, hugely scalable. But do you go beyond that and actually provide libraries of algorithms that developers can then use and piece together into a...
It's just an interesting area at the moment. I think we've no products in that area, but I think there is a number of, for example, in machine learning, a number of great open source libraries that almost integrate into every possible platform. And instead of replicating those libraries, I think we're helping other people just discover them and make sure that there's packages readily available.
Yeah. Just to build on that, I think cloud and mobile changes everything. I think we're at the beginning of one of the most disruptive time frame in IT that we will see in the next 5 to 10 years. And this is just getting going. And a lot of it is happening because of what I call as a super convergence of mobile, big data, analytics, social, cloud, and millennials all coming together. And we've never seen that in the history of IT, all of these forces. And in terms of cloud, I kind of differentiate two types of cloud. One is what I call as the computational cloud, where you can store and compute near infinite capacity. Second is what I call as the cognitive cloud, the cloud where you have intelligence and analytics built into it. And that sort of ties into how at Watson and IBM, we see this as the beginning of a third generation of computing that we call as cognitive computing. The first generation was tabulating machines. Second generation, where we are now, is programmatic machines. And now we get into cognitive machines, which are able to exploit cloud and mobile and big data to solve problems at a scale and reach that was never possible. The entire field of medicine, you know, how we teach medicine, how we practice medicine, and how you get paid for medicine is an area. Education, there are lots of industries that I believe in the next 5 to 10 years, we're going to see some massive disruption coming up.
So the skeptic would say that the strategy here with IBM is to generate more large services engagements for IBM Global Services to go work for big corporate clients to implement this technology that the client otherwise...
Well, that's part...
How is that not the case?
No, but that's part of our strategy. In fact, the way I describe the Watson commercialization strategy, we're commercialization Watson in 3 stages. I call it high value, high volume, and massive volume.
Right.
High value is where we took Watson towards cancer, and we have demonstrated that new cancer therapies, where a leading cancer institute can come out not in 3 years, but in 10 months when we applied Watson there. So that was the initial proof point of high value.
Elaborate a bit more on how that was done.
Right. Can I just come back to that? Sure. And I'll just put these pieces. So the high value is that. Then high volume is where we started applying it for call centers, financial services, retail, anywhere there is a lot of data that machines can help augment your cognition. And then massive volume is last year we opened up the Watson API and a Watson Cloud. And last week we announced $1 billion investment from IBM in Watson, and a $100 million investment fund for entrepreneurs to build applications on top of Watson. So the model is not exactly global services, that'll be a piece of it, but the model actually is like the mainframe. Open up the Watson mainframe in the cloud and let other people write applications on it, and we will serve differentiated capacity into it. Particularly in healthcare, the reason we took healthcare as a big area to go after is it's a large problem that is full of unstructured data. Cancer, medical information is doubling every 5 years. 1 out of 5 cancer diagnoses and treatments is considered to be incomplete. And doctors are spending less than 5 hours a month reading up on medical journals. So as a result, we felt a system like Watson could be a great navigation device and as an assistant to the doctor to do better evidence-based diagnosis. So when you're seeing a patient, it is reading through 6 million pages of cancer research. It's looked up 45,000 past cancer records, and it is matching the doctor's notes and nurse's notes to what the likely path of treatment might be. It is not telling you what to do, it is giving you probabilities, going back to you, as to what course of treatment you may want to consider. So I think it's a new paradigm in terms of how machines are going to be using unstructured and structured data to start augmenting our capabilities rather than machines being giant calculators. I think we'll look back 5 years from now and we will say that computing before Watson was nothing but giant calculators. Computing after Watson was the beginning of not just Watson, other technologies too, of machines that learn and think.
So you described some very successful implementations within healthcare. What are the next industries that you think that this technology could be most successful?
So we've already done healthcare, and now we have done financial services, insurance, and retail. We've announced customers in that. We are having that unique problem of, I call it, putting a shoulder to the door. The amount of demand for Watson has been far beyond what we had anticipated, and we are now having to roll it out. That's why we opened up the Watson Cloud, because we realized that we can't build all the applications on our own.
Leverage the
and we're going to leverage the entrepreneurial community to build a new class of companies on top of it.
Can I maybe take that question, but just for AI generally and not Watson? Because I think for the longest time, I think if you were a really smart kid coming through college or grad school and you wanted to do something really cool, you would try to do a Facebook clone or a Groupon clone or something. I think I think the saturation of sort of at least a lot of the conceived consumer services, it has and the success of things like Watson and before that Deep Blue, but and to some extent our own. I think it's inspired people that wow, you can do AI and you can really win big. And in an entrepreneurship class I mentor for at Stanford. A couple of years ago, one of the projects was a farming robot. That they actually built an autonomous little robot that would just roll up and down the fields, use image analysis, and zap weeds with a laser. And this was used for organic farming, where you're not supposed to spray pesticides. And that's a company now called Blue River Systems. And so you're seeing kind of more and more, I think, just younger kids coming up, and you're seeing venture capitalists. This used to be a crazy thing. Like, I'm not going to fund that. It's got scientific risk, right? You just go with something that seemed to have a fewer risks along the way to some VC exit. But I think now, COSA Ventures, my own Series A fund, MDV, and Blue Sky, a lot of investors now have AI as a thesis. And that's just these two things both tilt, in the direction of more innovation, of seeing successes, being in many universities having large groups of kids that are well trained, and now able to get funding for it as well. Not to mention just the IT setup costs are negligible compared to what they used to be. So I think we're going to see this in just the answer to which industry is just all of them.
So it's actually what's pretty cool about the whole machine learning part is areas that. Much of the real work has been done by scientists here. And that they've been building software that's available for everyone. Now often I would never take software that comes out of any academic program and actually want to use it in production. But this is one of those areas where actually lots of open source software has been developed by scientists themselves, which are the core of most of these engines that are out there now. And so it is not as much that, let's say, the application area people are looking at how to improve the algorithms that are actually in there, but more the usage of them. So we have a real great core of fundamentally sound scientific software out there in open source for everybody to use. And so that makes it the difference from many other areas.
Yeah. Let's maybe switch gears a little bit and talk about some of the controversies associated with this and some of the kind of potential negative impacts on society that we could see going forward. So, been starting off with liability. Maybe Manoj, you could comment on this. So, what happens when this goes wrong? What happens when the machine misdiagnoses a patient through some bug in the software? Someone's hurt, there's a problem. Who's going to be responsible for that, and how do we sort through that?
Yep, this is one of the topics that I spent a lot of time in the early days, and also any new technology that comes about brings about both the good and the concerns. And in the case of medicine, we spent a lot of time with insurance companies and patients on this. Our philosophy and what we are finding is that at the end of the day, Watson or a system like Watson is not making the decision. Right? It is an advisor. So every Watson application is called an oncology advisor, a diabetes advisor. It is not replacing the doctor, but augmenting the doctor. That's one piece. And the second part is there are existing models today. When a doctor sees you, he or she looks up a textbook and then treats you. And if you die, your family does not sue the textbook publisher, right?
There's a bit of a paradox in there, though, because on the one hand, you're saying we can hugely improve the performance of the doctor by creating a machine that can give a better answer. But on the other hand, you're saying it's the doctor's responsibility to figure out whether that's the right recommendation. And if it goes wrong, it's the doctor's fault, not the machine's fault.
It's a next generation tool. It's a dynamic textbook, for lack of a better word, which is aggregating the information and providing you, much like a Google or a WebMD would do when you're looking up. Many doctors have told me that they're surprised at the number of patients that walk into their offices with a printout from Google saying, this is what I found in self-diagnosis. Tell me, what do you think about it? And they look at Watson as a good tool to sort of offset it, to say, OK, I've got my own tool that has all the medical research that I trust that I'm going to use to sort of give you my better informed decision. So it's more of how you position and how you use the technology, at least in the case of Watson, which is more as a decision support system, not a decision-making system.
And I think what's really important there is to think about that decisions that we make are never black and white. If things would be really, or if a decision would always be 0 or 1, then that makes it easy. I think most decisions we make are sort of statistical. With some likelihood, with some confidence, I think this is the answer. And what these systems can help you with is actually putting a number next to it. Saying that, with 95% likelihood, this is this particular outcome, or that's this particular diagnosis. Making those numbers real, I think, help you with your confidence in whether you're making the right decision or not.
Right.
Can I counterpoint, I guess? So sometimes we do decision support, and sometimes we just have autonomous systems just doing. In the medical field, Johnson & Johnson has an anesthesiologist robot, and the job is not to assist the anesthesiologist, but to completely replace them for a class of operations. And embarrassingly, even though I'm supposed to be this AI dude, I only discovered the Johnson & Johnson robot because I'm also the director of a public company, Rocket Fuel. And in a newsletter, there was an article about director's liability for companies that are producing autonomous medical devices. So conclusion, we're not sure, but you should probably ask a lawyer and dial up the insurance. It is perplexing, though. I mean, but I think probably in the end, it's funny. Asimov, we talked about 3 laws of robotics earlier in the morning. Robot psychologist was the occupation of the future, and you can kind of see that coming in the degree of complexity that at least our autonomous systems exhibit at times. It's quite puzzling sometimes what they're doing and how do you diagnose. So it's I see it as being kind of messy versus clean in the future, trying to figure out liability.
Yeah, I mean, I wanted to add something because it's such a fascinating question, isn't it? I think actually when you look to the future and you look to computational models that are making decisions, actually what we need to do is reevaluate what we think of as justice and how we deal out justice. And I think actually that's something that's been coming for a while. I mean, if you look at recent research into self-awareness and actually the way the human mind works, the concept of looking for blame and looking to blame autonomous individuals for their actions doesn't actually help very much. And if we move to a justice system that is more based around looking at outcomes and trying to create systems that provide the best outcomes, I think hopefully what happens as we wrestle with some of these philosophical questions around AI is that it actually forces us to rethink our models of justice.
So actually, coming back to the 100% question, so we at one moment launched a service called Mechanical Turk. Yeah, so this is this human intelligence actually sit behind a computer interface. And the first tagline we had with it was that it was artificial intelligence. Yeah, because there were cases where, how this originally started was that we allowed customers to upload any image that they would want it on a product page. And they would really upload any type of image there, including lots of adult content. Now, if you want to do automatic processing of those images, and with 100% certainty know that there are no adult images in there, that's almost impossible. We have not reached any type of scale in terms of our N algorithms that we can really say that with 100% certainty there is no adult image in this set. However, if you have a number of humans looking at it, they need only 10 milliseconds to make that decision, yes or no. And so there's still many, many cases where we as humans are much better at making decisions with 100% certainty than that computers are.
I think another element of this is replacement of tasks that humans are undertaking currently. One way this has been talked about has been a sort of a second industrial revolution, whereby for a long period of time, all the manual tasks were automated, and that put a large part of the population out of employment, unemployed, and society had to adjust. Now we're seeing knowledge workers, their tasks being automated, and potentially a similar thing. George, would you like to, what's your perspective on this, and how do we make those adjustments as society?
Yeah, it is something I worry about. I'll put in a plug for a book called Mana by Marshall Brain. He's actually the founder of HowStuffWorks.com, but he worries about this stuff too. There's actually just recently a class at Stanford last quarter about sort of societal implications of AI and advanced technology. So the worry, so if the answer to which industry is sort of next, if the answer is all of them, and really many kinds of knowledge work around that, the worry that a lot of folks have, like there's a book, Race Against the Machine, about this too. The worry is, what if our historical pace of ability to sort of evolve as societies in response to automation, the name Luddite came from the people who tried to smash the Jacquard looms, which were displacing manual employment and labor. What happens if you have Luddites what if it's not just the weavers, but 50 job functions that all get automated at once? So I do feel like it's a problem for governments to begin thinking about. There's the easy answer is, well, everybody go onto Coursera and learn some new skill. The other approaches being looked at, right, are European governments are kind of ahead of America on this, living wage or reducing work hours. Because the theory is, take the farming robot that zaps weeds. Well, isn't that nice that someone doesn't have to waste their whole life just bending over, pulling out weeds? But on the other hand, if that was how they got food and shelter, maybe they would like to continue doing that. But if we really do have the society of abundance, how do we figure out how to share it in a world that doesn't require labor in the way that ours does today?
I think on the issue of replacing human beings, I think there are two facets to it. One is around making human beings more efficient versus making it more effective. So there will be places where, just like the industrial automation, replaced the textile worker in Birmingham, and then as it moved on. So there is a portion of this technology that is going to replace human jobs and conceivably move them up to doing more higher value activities. But there is also another piece that this technology does, which is it democratizes information. I use the analogy of with the cancer folks at MD Anderson in Houston. It's like having the formula for Coca-Cola, but only having one fountain to dispense it in Houston. That's the world's best care for cancer. So if you are unfortunate to have cancer, you have to go to that Coke machine in Houston and get that treatment. Technology like mobile and cloud and Watson could act like a bottling plant and distribute that through a cloud and mobile to anywhere in the world so that you can start using devices that are pervasive to start accessing medicine where you need it. So it's both replacement as well as scaling and reach, I think, which the technology enables.
So the other sort of controversy around this is that, AI and that family of technologies makes us much more efficient as humans. It could also make us a lot more efficient at a lot of the bad things that humans do, discrimination, coercion, exclusion, these type of things. Stealing, theft, crime, all the positive stuff, and also all the negative stuff becomes a lot more efficient with AI. How do we sort of sort through those type of things as society?
Because I think on both sides of that, good and bad, we use the same technologies. I think we've seen that around recent spying accidents or programs, they've just gone digital as well. I mean, it's not like spying wasn't going on before this. It's just they've just grown up with the times as well. And so, take for example fraud. I don't think at Amazon we could do the level of fraud detection that we're doing without machine learning. We could put millions of humans against it, and I'm not really sure whether we could reach the same level as that we can with algorithms. So, while both the bad guys who I think have probably bigger budgets than what we have, are able to hire more PhDs than we can, pay better salaries, and their software only needs to work for 2 minutes. We actually have the same power on the other side to do good. So it remains the same human issue. We can use the technologies on both sides of that fence.
I think in the U.S., it's basically computers that get to decide if you're allowed to buy a house. Fair Isaac for a long time has really kind of dominated the market of credit scoring. Everyone in America tends to know, at least at some points in their life, their FICO score. And the solve for this was, it's actually regulated. The algorithm has certain limitations on it. It needs to be expressible so that regulators can ensure it's not using ethnicity and other factors we've decided as a society we don't want to consider, right? So I think in some of these cases it's just a matter of figuring out how to take what we might have thought of as common sense in regulating human activity and just figuring out how can we still have that level of oversight over the machines. In theory, it's actually easier because you can look at the code versus if you had 1,000 just people distributed around the world at bank branches, you would never really know if they were, for example, being discriminating or not.
Do you think we'll have robot police that will send against the robots to stop them behaving badly, in the sense that algorithms that look algorithms for good looking for the algorithms for bad and weeding those out?
Definitely in advertising, it's sort of spy versus spy. I mean, there's a set of bad actors that know they can just create fake websites and send robot traffic to it, and if you're not smart, you'll end up buying ad space on that fake site that only has robot visitors. So there is going to be some kind of arms war on the good and bad sides.
The other obvious element here is privacy. I mean, in order to make all of this work, we've got to collect all this personal information, and there's a sort of a explicit contract between consumer and provider that we'll give you our information, you do something for us that's going to make our lives better. I mean, other panels will cover privacy, but just touching briefly on the topic, and maybe Ben and George, how have you sort of contended with this as you built up your businesses?
Yeah, I think it's a serious question, and one that is increasing in awareness all the time. I think the reality is the systems of the future will run on data analysis, and there's kind of nothing we can do about that. If you want intelligent systems, you have to give them access to data. So I think that's not really the question. The question is how, as a business that's working in this space, how do you earn the trust of the consumer? And I think that there's kind of two sides to that. One is the services that you provide. The onus is on you to demonstrate that the value that you're providing to your customers justifies the access to that data. And of course, the other side of it is the systems that we have in place for storing and processing that data. And this is why I think actually platforms like AWS are really important, because this standardizes across the industry how we capture and store and process that data, and it makes it more transparent. But I think from our perspective, it's all about earning the trust of the consumer, and that has to be done over time. It can't be based on a series of 5 statements about what we will do with your data. We have to prove it in practice.
George, have you got any?
Yeah, well, very briefly on online advertising, I think the industry has been very careful about privacy, even since really digital advertising began. There's a number of bodies in our industry that have principles for the use of online data. At Rocketfield, we've basically elected to be just sort of a space of opportunities there. We've elected to be as sort of cautious and careful as we can, so we don't know who any of our users are. Everything is represented anonymously. So per the conversation this morning saying consumers ought to be able to know what a company knows about you, if you were to ask me what do we know about you, I don't know, because we wouldn't be able to match you with any of the anonymous identifiers in our system.
Anonymous, right. Well, sadly, we're out of time. I think the interesting point here is there's been huge advancements in the technology over the last 10 years, the enablers of cloud, mobile data, open source algorithms. I think the questions now are all about how do we handle this technology now for society to make sure we get all of the benefits and mitigate some of the risks associated with it. Thank you very much to our panel. Thank you all.